Paper prototypes are low-fidelity prototypes that are an excellent choice for early design iterations. As you saw in the previous video, a paper prototype is a physical mock-up of the interface, mostly made of paper. It's usually hand-sketched on multiple pieces of paper with different pieces showing different menus, dialog boxes, and window elements. The key difference between mere sketches and a prototype is that of interactivity. A paper prototype is brought to life by a design team member who simulates what the computer would do in response to the user's clicks and keystrokes by rearranging pieces, writing custom responses, and occasionally announcing some effects verbally that are too hard to show on a paper. Because a paper prototype is interactive, it can be tested out by the user, as shown in the previous video. Just give users a task to do and watch how they do it. A paper prototype is clearly low fidelity in both look and feel, but it can be arbitrarily high in breadth at very little cost, just sketching. Best of all, paper prototypes can be high fidelity in depth at low cost, since a human being is simulating the backend. Engineers are not needed to do the coding. There are many different versions of paper prototypes. Examples include screen storyboards, screen mockups, wireframes, card prototypes, and screen sketches. Screen storyboards are a sequence of screens that focus on a specific user action. They don't capture every detail, just system's major functionality, and hence they are limited in scope and more rigidly linear. They are usually created on a large piece of paper, which consists of all the screens that will be part of the proposed system. The goal of a screen storyboard is to show relationships between different screen sketches or mockups. Arrows and numbers are often used on the screen to show how screen flow is organized. Screen mockups are typically created later in the design process. They usually have a high look and feel fidelity. Paper templates are often used to create screen templates. These days, you can purchase UI stencils, as shown here, to create screen widgets or icons as well. Using stencils will help you increase the look fidelity of the paper prototype. You can purchase screen templates from different websites. Wireframe can be created as screen sketches for websites. They are essentially for organizing information on the screen. They can be used to establish the basic structure of a page before visual design and content is added. Another way to show flow between screens is by using cardboard prototypes. By embedding your screen sketches and mockups inside a paper prototype, you can increase the feel fidelity. In this example, a cardboard prototype has been created for a smartphone. Screen sketches have been inserted inside this cardboard prototype. The designer will simulate computer's actions when the user will interact with the screen by pulling this piece of paper up and down to show the next screen. The last example is sketches on pieces of paper. You saw examples of screen sketches in the video. On the right is a prototype that is completely covered with transparency. Users can write on it directly with dry erase marker, which just wipes off. With multiple layers of transparency, you can let the user write on the top layer, while you use a lower layer for computer messages, selection, highlighting, and other effects. Here are some of the elements that are typically used in a paper prototyping toolkit. Some of these elements are necessary for creating the actual prototype, while the others are needed during the user testing. Although standard online paper works fine for sketching, You will get better results from using sturdier products like poster boards and index cards. My recommendation is that you use poster board to draw a static background, usually a window frame, like in this picture here, and then use index cards for the pieces you will place on top of this background. So index cards or pieces of paper that you are going to put on this background. You can cut index cards down to sizes for menus and window internals. Roll-on glue stick is a must. It helps you make all your pieces stick together, so they stay where you put them during the user's testing. You should also try to make use of transparencies if you are going to have the user do a lot of typing. If you have many similar elements in your prototype, use a photocopier to save time. Here are some recommendations for making a good paper prototype. Make it larger than life. A paper prototype should be larger than life size because remember that fingers are bigger than mouse pointers and people usually write bigger than 12-point font. So it will be easier for you to use your prototype if you scale it up a bit. It will also be easier to see from a distance, which is important because the prototype lies on the table and because when you are testing users, there may be several observers taking notes who need to see what's going on. So big is good. Don't worry too much about color in your prototype. Use a single color. It's simpler and it won't distract attention from important issues. Needless to say, don't use yellow. Replace tricky visual feedback with audible descriptions. You don't have to render every visual effect in paper. Some things are just easier to say aloud. For example, the basketball is spinning, a progress bar is popping up. If your design supports tool tips, you can tell your users just to point at something and ask, "What's this?" And you will tell them what the tooltip would say. If you actually want to test the tooltip messages, however, you should prototype them on paper. Lastly, keep pieces of your prototypes organized. This is actually very important during the user testing. Figure out a good scheme for organizing the little pieces of your prototype. One approach is a 3-ring binder with different screens on different pages. Most interfaces are not sequential, however, so a linear organization may be too simple. 2-pocket folders are good for sorting big pieces and letter envelopes. The open flap are quite handy for keeping menus. Now let's talk about some of the advantages of using paper prototypes. Obviously, they are faster to build. You can draw many sketches in the same time it would take you to draw one user interface with code. For most people, hand sketching is also faster than using a drawing program to create the sketch. Secondly, paper prototypes are easier to change. You can even change it during user testing. If part of the prototype was a problem for one user, you can scratch it out or replace it before the next user arrives. Surprisingly, paper is more malleable than digital bits in many ways. Paper sketches also encourage people to be more creative and make suggestions easier. However, there are some disadvantages of paper prototyping, but all these disadvantages are easily mitigated. First disadvantage is that they are thrown away at the end of the project. Since paper prototypes are created quickly and iterated several times, designers do not feel bad about throwing them away at the end of the project. Secondly, specifications are less detailed, making it difficult to code. But to convey specifications to engineers, designers can add notes or create a design document to convey important messages to the coder. Thirdly, a facilitator is needed to convey the idea to the user. These days, we have software that can do a lot of work that facilitators use to convey idea to users. It is also possible that paper prototypes will be less compelling for users. Designers should engage their users with paper prototype by eliciting their feedback and giving them the opportunity to co-design. This can help users understand the purpose of paper prototyping better. Lastly, the ability to check errors is limited with paper prototyping. This is okay because it is better to focus on testing concept with paper prototypes as opposed to very fine-grained interactions.